Welcome to my video on unit vectors. This is the fourth video in the series on vectors, and the vector series number 3 is at the back of this video. You can get the link to it. In this video I want to talk about unit vectors. They are dimensionless vectors with a magnitude of 1 and point in any convenient direction. What that refers to is depending on the coordinate system you're working in. In this case, we're going to be dealing with three-dimensional Cartesian coordinates, our normal x, y, and z coordinate system, and then the unit vectors are going to be these three little vectors right here, I, j, and k. And when we write them out normally, we'll put them in bold or we'll put a little hat over them to signify that they are unit vectors. And they go correspondingly to the x, y, and z direction. So a general vector, the A, can be written as a sum of three vectors, each parallel to the coordinate system. So this would be in this notation right here, where you have the component AX times I, and then AY parallel to the J-axis or the Y-axis, and then AZ, which is along the Z-axis, and that's the unit vector K. Now we can write this in a triple notation, which is a kind of a shorthand where we just take these individual components and write them out and just assume that the I, J, and K are there. So you'll see these unit vectors written in both of these formats. Now let's look at the Cartesian coordinate system, and then this is going to be our I, J, and K. Those are our unit vectors. They're of length 1, and they point in the X, Y, and Z direction respectively. So if we want to have a general displacement vector R, which goes out to a point P at X, Y, and Z, the X direction is X times I, the Y direction is going to be Y times J, that unit vector, and then the Z direction is correspondingly Z times K. So that the sum of those, that, and that, those three give us the position of P. So that's what the unit vectors are all about. Now I want to look at the addition of unit vectors. And what we want to do here is we want to take A plus B, and we're going to write it in this format that we just discussed. So it's AX plus AY times the J plus AZ times the K unit vector. Now we do the same thing for the B, so it's bx times I plus by times j plus bz times k. So there is written out in this notation. Now what we're going to do is we're going to combine like terms here in front of the i's and in front of the j's and in front of the k's. So we can rearrange these terms. So we're going to get AX plus BX parallel to I plus AY plus BY in the J direction plus AZ plus BZ in the K direction. So that's our basic formula. So now let's do an example of that. We've got two vectors. A is equal to 4, 0, 1. B is equal to 2, minus 5, and then 1/3. So let's add those together. First of all, let's put this in the unit vector notation. So that's 4i, because the 4 corresponds to the I. There's nothing in the j direction, so we don't put anything there, and then there's 1 in the k direction, plus k. So that's written in the unit vector notation. Same way here, 2i minus 5j plus 1/3 k. So there's our two vectors that we want to add together. Now we saw from what we just developed just a second ago, we just add the individual components. So we're going to add the i's together. And do the same thing with the j's and the k's. So when we do that, we're going to have 4 plus 2 in the I direction. Now, here we've got 0 and we got -5, so that's going to be -5 in the j direction. And then in the k direction, we've just got a 1 and a 1/3, so that's going to be 4/3 in the k direction. So that's going to be our vector. Let's write that out. So that's going to be equal to 6i minus 5j plus 4/3 k, which can also be written in the triple format of 6 minus 5 and 4/3. So there's the sum of those two vectors using the unit vector notation. Now we want to look at the case where we've got the multiplication by a scalar of a unit vector, how that works out. So what we've got here, this is going to be a scalar, and there's going to be our general vector, and we're going to write that as the form like we've always done. There's the I, j, and k. Now we just carry through the c, so it multiplies each of the individual vector components. So doing an example of that, so let's let a be equal to 4, 0, 1. Now minus a, carrying this through, is just going to be equal to -4, 0, and -1. So it just multiplies through there. So that's going to be in the unit vector notation. That's 4i plus k. And over here we're going to have -4i minus k. So there's the answer if we just take the negative of a vector in unit vector notation, and it's also written out in the triple format. Do one more example. Let's take 7 times a. Now we just distribute the 7 out, so it's 7 times 4, 0, 1. There's our triple. That's going to be written as 4 times 7 is 28. 7 times 0 is 0, and 7 times 1 is 7. So there we have it in the triple notation. We write it out in the vector notation, unit vector notation. 28i, nothing in the j or the y-axis, and 7k. So there's our answer if we multiply this vector a by 7. Next, we want to look at another example, and what we're going to do here is we're going to find the resultant vector in component form and the magnitude for the three vectors. So we're going to be giving three vectors, and they're going to be given to us in the triple format. So we know our resultant vector now is just the sum of p plus q plus u. So that's really what we're looking for. The resultant vector is just the sum. So now we can add these together. So the first component is going to be the 2 minus 4 and 2. So we've got the first component is 2 minus 4 plus 2. Now the y component is just going to be taking the second term, so it's the 2 minus 4 and 2 again. So it's 2 minus 4 plus 2. And then the z component is just 2 plus 0 plus 7. And so let's do the math on that. 2 minus 4 is minus 2 plus 2, so that is a 0. And then the same thing here. We've got 2 minus 4 is minus 2 plus 2. That's a 0. And then 2 plus 7 is equal to a 9. So that is going to be written as just 9k. So there's our basic vector written in both notations. But now we want to know the magnitude of it. So the magnitude r, the length of r is what we're looking for, is just the square root of the components added together. squared, rx squared plus ry squared plus rz squared. Now in this case, rx and ry are both equal to 0. We just have a z component. So it's the square root of 9 squared, which is just equal to 9. So our magnitude is 9, and there's our basic vector. That's the resultant vector, and it has magnitude of 9. Well, I hope you got something out of this video and learned a little bit about unit vectors and doing some addition with them. And if you did, like and subscribe to my channel, and thank you for watching.